Very good evening, everyone. Am I audible? I hope I'm audible right now. Yeah, very good evening, all. Good evening, everyone. Very good evening, all. So, I welcome you all for engage your learning experience with Pantech eLearning anytime, anywhere, at any places. So, today is day 4 of 21 days Masterclass series on autonomous vehicle. So, let's talk about some important topic today. What is that? So, we are going to discuss about the one app from the MATLAB Simulink, that is the ground truth labeling app. So, what is this exactly? What is the meaning of this ground truth labeler app and why we use this app in MATLAB Simulink and how this app is useful for the autonomous vehicle? Let's discuss about that things. First, a ground truth labeler app. So this is a one kind of the tool in MATLAB Simulink. It helps you mark and you can identify the objects or features in a videos and image sequences or a lidar point clouds, lidar point sequences. So it's like drawing the boxes around the objects in pictures to tell a computer, to tell a MATLAB software what they are. So then why use this app in MATLAB Simulink? So we would use this app to label the data from the various sensors data, to label the data from camera sensor and lidar sensors together, which is very much important for understanding what's happening around the vehicle. It's like detecting the car or detecting the road signs or detecting the any obstacles on the road and detecting the pedestrians also. That is why we use this one. And what we will learn from this app. So what you will learn from this ground truth label app. First one is how to label the data. You will learn how to mark and how to label the different types of data, like the images or videos, which is a very important task. It's like teaching a computer to organize any objects. So that is that how to label the data. Then how to combine the data from the different sensors. So you will learn how to put together information from the cameras and lidar sensors at the same time. So this is a very crucial for making a sense of what's going on around the vehicle. And next one, you will learn how to do your work more quickly and accurately. So which is always useful when dealing with a lots of data. At that time, we use this ground truth labeler app. So what is the other alternative way to label and detect the objects? So there are a lot of ways. I will explain one by one. So first one is the computer vision toolbox. What is a computer vision toolbox? So MATLAB's computer vision toolbox, it offers a wide range of functions and algorithms for particularly object detections and tracking and recognitions in images and video sequence. And this is the computer vision toolbox. Next one is the deep learning toolbox. So if you are dealing with the complex objects, detection the task, detection the object, especially those involving in the deep learning method, you can utilize the MATLAB's deep learning toolbox. This toolbox it provides the pre-trained models for the object detection, such as the RCNN or a YOLO algorithm or a SSD algorithm like that. So which you can use to detect the objects in a video sequences. So next one is the OpenCV with MATLAB. So MATLAB also provides support for the OpenCV. So we know the OpenCV is an open source computer vision library. You can use the MATLAB's interface to OpenCV functions to perform the object detections and object tracking and labeling in the video sequences. At last, you can write your own program. So you can write your custom scripts or custom script functions using the MATLAB's programming capabilities to implement your own object detections and object tracking algorithms. So these are all the alternatives you to label and detect the objects in a video sequences programmatically. And then how this app is useful for the autonomous vehicle. So this is the app. It's look like it's a MATLAB Simulink app, that is the ground truth labeler app. So this app it's look like this only. So I will show you after this theory session. And now how this app is mainly useful to the autonomous vehicle. So what are the applications? So first one is the training data creation. So this autonomous vehicles, we know that rely heavily on the machine learning algorithms to perceive the data and understand their surroundings. At the time, this ground truth labeler app helps in creating the high quality training data by accurately labeling the objects such as the car or a pedestrian or a road signs or other relevant elements in the environment. So this labeled data is then used to train the some perception algorithms and then enabling the vehicle to recognize and react to the different objects and different scenarios on the road. Next one is the sensor fusion. So we know the autonomous vehicles typically use multiple sensors, including camera, lidar, radar, and ultrasonic sensors to perceive their surroundings. This app allows a simultaneous labeling of the data from these different sensors. So to get a comprehensive view, comprehensive perception about the environment. So that is why we use them. And next one is the algorithm development and evaluation. So this app provides a tool for developing and evaluating the detection and tracking algorithms. And then automatic labeling and validations testing. So here this label app, ground truth label app is a very much essential for the validating the performance of a autonomous vehicle system. Because the labeled data generated by using this app that can be used to test the vehicle's perception algorithm in a simulated or a real world scenario. So this validation process helps in identifying the any weakness or areas for improvement in the perception system, perception algorithm. So that is why we use them. So overall, this ground truth labeler app plays a crucial role in the development and testing and also the performance of autonomous vehicle system. So next talk about the description of the ground truth labeler app. We know this app is a powerful tool for labeling the important data in videos and image sequences or point cloud sequences from the lidar sensor. So how it can help you? So first one is the simultaneous labeling. So you can label the multiple signals from different sources that show the same scene at the same time. So this ensures the consistency across every data. Next one is the various labeling. So what is the various labeling options? So you can define the different types of labels like rectangles or polylines or pixel regions to mark the specified areas or specify objects in your data. So this flexibility, it can allow you for the detailed and accurate labeling. So that is why this it has a various labeling options there and also multiple viewing options. So this app lets you view the labels from the different angles simultaneously. That helping you understand the relationship between the objects in your data. And then automatic labeling. So you can use built-in algorithms or you can create the custom algorithms to automatically label the data and saving the time and effort in the labeling process also. And then exporting the labels. So you can export these labeled data in a format that can be used for system verification or training the machine learning models. And also you can display the synchronized signals such as the data from a CAN bus or alongside your labeled data using the driving connector or connector API. So this ground truth labeler app, it offers a comprehensive set of tools for efficient and accurate labeling of the data. So which is a very crucial for various tasks like training the algorithms model or verifying the system performances. So first most thing we are going to do in our MATLAB ground truth labeler app. So first we are going to do the load signals. We are going to load the signals from the different data source in app. So for that first we should know the image sequence, image signals and point cloud signals. So what does it mean? So you can label the two types of signals. First one is the image signals, another one is the point cloud signals. So these signals are based on the images and can be loaded from the sources like videos or image sequences. So they represent the visual data captured by the cameras or any sensor. Next one is the point cloud signals. As I said earlier, so these point cloud signals are based on the LiDAR data only, and that can be loaded from the sources like sequences of a point cloud files. So they represent the 3D information captured by the LiDAR sensor. So in this example scenario, now we are going to do the one demo here. So we have to load a video that representing the view from the camera sensor and a sequence of point cloud files and that representing the data from a LiDAR sensor mounted on a vehicle. So both the signals capturing the information about the same driving scene but from the different perspective. So the camera, it provides the visual images while the LiDAR, it captures the spatial information. Spatial information around the environment. So by labeling these signals simultaneously, you can create a comprehensive understanding of the scene, understanding about the environment. So for tasks like object detections or object tracking in autonomous driving applications. So for that, we need a MATLAB Simulink software here. So now I am going to open the MATLAB software. So just type the MATLAB. It will take a few seconds to open. I hope everyone can understand the basic introduction about the app and how to open the app like that. So what you will learn from this app and how to use this app for a especially autonomous vehicle. I hope everyone should understand the information. Now, so the MATLAB software is open. So go to app. So here under the automotive, here you can see the ground truth labeler app. So to open the ground truth labeler app, you can use the MATLAB command window also. So just type the command ground truth labeler. So the ground truth labeler app will be open. Alternatively, you can open the app from the app tab under the automotive section. So this is the ground truth labeler app homepage. So before we are going to load the signals, I will tell you in the some procedure. So wait, this is the app homepage. In ground truth labeler app, you can load the signals from the various data sources. So each representing the some different types of data, that is the video source. Another one is the PCD files. Other than data source also will be there. I will explain you. So first one is the video source. You can load a video signal from a MP4 file. So you can load a video signal as a MP4 file. So this file contains a single continuous video frame that you can analyze and label within the app. So that is a very easy. And next one is the PCD files. So PCD files in the sense that is the point cloud sequence source. So this is the point cloud data. So the source is typically a folder that containing a sequence of point cloud data, PCD files. So these files collectively represent a series or a spatial data points captured over the time that forming a point in a cloud sequence. Next one, other data sources are also available. So additionally, this ground truth labeler app supports the loading sequence from the other types of data sources, such as the rows bags. So that is, what does that mean in the sense? These source bags, these sources can contain the multiple signals, each representing the different aspects of the data that being captured. So for example, in the context of the autonomous driving, so rows bag, it might include signals from the various sensors, LiDAR, radar and camera. So this is what you can load the signals in the format only, video sources, that is the MP4 and PCD files. Now we are going to open the MATLAB software again here. Yeah. So this is the ground truth labeler app. So first you have to load the video. So for that, go to the app. So from this app here you can see the import. So import, click this import and add the signals. Just click add the signals. After that, one window will be open. So once you click this import, add these signals, and here you can see the one window will pop up here. And from this window here, we have to add our sources. That means signals. So the add and remove signal. It's a dialog box. It contains the source type and some timestamp. So first I am going to load the video sequence. So for that I am going to select the video, and after that go to the file name. So in this file name you can browse your video file. So in the file name parameter, so browse for this video file. So I am going to browse my file here. Wait, I'm going to browse my file. Okay, so this is the file path and I'm going to select this one. Yeah. So now, after you browse this file name here, next click add to the source. So this video loads into the app and the app reads a timestamp directly from that video. So the source tab, source table, it displays the information about the video data sources. Now I am going to add the source. Here you can see. So this is the add source, and next I am going to add the point cloud signal. So for that, again you go to the source type and wait. So first you have to click this one and again wait a few minutes. Yeah. So here you can see our successfully loaded the video, and now I'm going to import the point cloud sequence also. For that, go to import and add the signals and go to source type, select the point cloud signals. So with this point cloud sequence, the dialog box, it displays a new option. So that is the point cloud sequences. So in the folder name, you have to browse your LiDAR sequence folder, which contains the sequence of point cloud files to load. So next we have to set the parameters. Set the timestamp parameters from workspace. So I am going to use from the workspace. And then duration will be, so click this one. So before I am going to browse my point cloud sequence. Yeah, here is my point cloud sequence, LiDAR sequence here. Now I am going to change this from workspace. Then click OK. So first you have to select your path in this one. So you have to select your path here also. So I'm going to select. So first you have to select your path. Wait. So where all the video files and PCD files, that root path here we are going to select. Yeah. So now you can load these signals. So again go to add signals and select the point cloud sequence and browse that file also. So select the file folder and use to from workspace. Wait, just a minute. So this is the MATLAB homepage. This is the MATLAB homepage. From this homepage here, go to app and select the under the automotive. Here you can see the driving. Sorry, under the automotive here you can see the ground truth labeler app. This is the ground truth labeler app. So first we have to import the video sequence. So go to add signals. So just select the video and go to browse and select this one, select this path. Copy this path and paste it here. Copy this path and paste it here. So this one is from file. So first we have to set the timestamp parameter to from workspace. In the import from workspace dialog box, it select the timestamp variable that you loaded for the point cloud sequence. Then click OK. Then click OK. Now we are going to add to the source in our signal in our dialog box. So then click OK here. So click add the source. The point cloud sequence also loads into the app. So this app, it reads a timestamp from the timestamps variable. So here the source table, it displays the information about the data source for the point cloud sequence. So first you should verify the information about the loaded signals. So for that we need some steps here. So go to the slide. So now I am going to tell you this masterclass, you can convert the masterclass into the 1 month internship. So what you will get during this 1 month internship? You will get the 30 days of live sessions and 90 days of recorded content and 10 plus source codes for autonomous vehicle projects and 30 downloadable presentation, and also you will get the internship certification. So this is the actual price of our internship, autonomous vehicle internship. Actual price is 1,999, and we are providing the discounted fees, that is a 699. So this offer, uh, is valid only for this 21 days live masterclass. So use this registration link to join as an internship user. And then we are providing another one exclusive internship offer, that is a 3-in-1 internship offer. So this 3-in-1 internship offer, you will get the EV design masterclass and MATLAB Simulink and autonomous vehicle. So you will get 3 big masterclasses under this exclusive offer, exclusive 3-in-1 internship. So what you will get from this exclusive 3-in-1 internship? You will get the self-paced 120 recorded content and weekly live sessions, and you will get the 3 certifications, and one more, you will get the 1-month internship certifications also. You will get the 20 plus project codes and projects based on the EV vehicle, electric vehicle, and MATLAB Simulink and autonomous vehicles. And also you will get the downloadable presentation and internship confirmation letters, and you will have weekly doubt session, that means hackathon sessions, that is a live class only. And this is the actual price 4,997, but we are providing the discounted fix, that is a 999. So use this offer, use this registration link to join as an internship user. And this is a way to get the internship. So now we are verifying the information about the load signals. So first we should verify our signals are correct. So for the video signal, the signal name should be the file name of the data source with the prefix video file name. So there is no file extensions. For the point cloud sequence, the signal name should be the same of the source folder. I will show you that one also. So open this one. Here you can see this is the video name. So video, it starts with video. There is no file extension here. And for the point cloud sequence, that is a LiDAR sequence, the signal name should be the name of the source folder. And next one is the source column. So what is the source column? So it should display the full file path to the signal data sources. And then signal type column. So for the video, the type should be the image format, and on the point cloud sequence, the type should be the point cloud. And then time range column. So it should display the duration of the signals, both based on the timestamp data only. I will show you that one also. Here you can see it. This is the video sequence. It should display the durations of the signal based on the loaded timestamp data. So both signals are approximately 10 seconds long. So for the point cloud sequence, here you can see the point cloud sequence, if the timestamp, or suppose if you have set it to default in the sense, at the time the time range value for the range is 0 to 33 seconds. So based on the 34 PZD files in that folder. So after verifying that the signals loaded are correctly, click OK. Then the app loads the signals and open to the first frame. So first frame, that is a video, and second frame which is for the point cloud sequence. So now I am going to view in a same single display. So how to do that one? So when you first load the signal, the app, it displays only one signal at a time. So like this, only one signal at a time. So to display the signal side by side, first go to the label tab. So first go to the label tab, and here you can see the display grid. So select the display grid, then move the cursor to select the one side by side grid. Once you click that one, here you can see the side by side window. So now the video and point cloud signals display side by side. Okay. So now we are going to watch the videos and point cloud sequence together. So now I am going to run this one. Yeah. So you can watch both of the videos and point clouds sequences at the same time by clicking the play button below the signal. So this is the play button. Now I am going to again watch the signals mean. So this is a play button. Just click the play button. So videos looks smoother because they have the more frames than the point cloud signals, point cloud sequences. So here by default, this app, it plays the frames from the signal with the highest frame rate. That is called the main signal. So for the other signal, it shows the frames that match the time of the main signal's current frame. So I am going to tell you the frame and frame rate. So what is the frame and frame rate? So frame is like a single picture in a video. When you watch a video, what you are seeing in a series of these frames that shows quickly one after the other to create a motion. So what is a frame rate? So frame rate is how fast these frames are shown per second. It is measured in frames per second. That means FPS. A higher frame rate means the video will look smoother because there are more pictures shown in the same amount of time. So for example, a video with 30 FPS, frames per second in the sense, it will show 30 frames every second. While a video with 60 FPS, it shows the 60 frames every second. So you can change the settings also. You can change the time. So you can change which signal is a main signal. By clicking the clock setting button below here you can see. This is the clock setting button. Now, here you can change your time. So, which signal is the main one by clicking the clock setting button below the slider. Now, after loading the video and LiDAR point cloud sequence signals into the ground truth labeler app, now we are going to describe the signals. We are going to define the labels in the load ground truth signals to the label procedure. So, we have to create the label definitions and label signal frames also. So tomorrow is that day. We are going to load the ground truth signals into the label. That means we are going to defining our label. So think about what you want to spot in your video, like a LiDAR data or a car or a people or a car plate or a number plate or a brake light, like that. So it creates a label for each of these things in the app. Next, we are going to label the frames. So go through each picture in the video and you can each snapshot in the LiDAR data also. So when you something you label, that mark it with the right label. So for example, if you see a car, then use a car label. If you see a brake light, then use a brake light label. So this helps you identify and keep the track of different things in your data. So which is a very important for understanding it better and making the software smarter about what they see. And this is all about tomorrow's session, that is the day 5, load the ground truth signals to the labeler app. So this is your today's task, day 4 task. So your task is to load any one type of the signals into the ground truth labeler app. That is a video or a LiDAR point or any one type of the signals you are going to load in your MATLAB Simulink ground truth labeler app. So this is a task for day 4. So before I'm going to conclude this session, I will tell you one thing. So this process of loading the signals into the ground truth labeler app, it's a very essential step in preparing the data for analysis and labeling the task. So now you have learned how to load the 2 types of signals, a video and LiDAR point cloud signals sequence into the app. So this process, it enables you to visualize and manipulate the data within the app interface. So this is all about today's session. Thanks to everyone. Thank you so much. Thank you very much. Thank you all for your active